So now the students, previous what we discussed about points, line segment and ray. So ray means, for example, race example, torchlight race. In the torchlight, the initial point we know. So the bulb is the initial point and it extends infinitely in other direction. Where it ends we are unable to say. So in the sun also, sun initial point of the sun rays we can say. So that is sun only the initial point. And race, where it ends we are unable to say where it ends. So that is why. So these are the examples of rays. Rays example, torchlight rays, bulb rays, sun rays, all these are examples of rays. Okay. So this about all this we discuss. So then after that what we are going to discuss, see here, polygons. So types of polygons, in the polygons also we discuss. So the definition, what is poly and what is gon. Poly means many, gons means angles, many angles. Polygon is a Greek word. Then polygon means many angles. In that polygon, so types of polygons we are going to discuss. So for the first one, regular or irregular polygons. So what is meant by regular polygon and what is meant by irregular polygon? The definition: if all angles are equal and all sides are equal. If all angles and all sides are equal, then that is regular polygon. So then how it is? Suppose, so 1, 2, 3, 4, 5. Here all the 5 sides are equal in length. So all the 5 angles are equal. If all the 5 sides and 5 angles are equal, then that is regular polygon. So in the regular polygon, all sides are equal, and all angles are equal. In irregular polygon, then how it is? In the irregular polygon, this is irregular polygon. So here sides are different and angles are different. If sides and angles are different, so then that is irregular polygon. Okay. In regular polygon, all the sides and angles are equal, and in irregular polygon, sides and angles are different. This is the difference between regular and irregular polygons. Okay. Now after that, so concave or convex polygons. What is concave polygon and what is convex polygon? So here, so convex polygon has no angle, so pointing inward. So it means no internal angle can be more than 180 degrees. So see here, so this is all the angles in this polygon is not more than 180 degrees. If the inside angle is not more than 180 degrees, so then that angle is so concave polygon. So this is less than 180, this angle is also less than. All the angles are less than 180 degrees. If all the angles in the polygons are less than 180 degrees, then that is concave polygon. Convex polygon. So then, so what is convex polygon means? No internal angle is greater than 180 degrees, that is convex. Then what is concave? Suppose a polygon is like this. This is a polygon. So here internal angle. So this internal angle is more than 180 degrees. If the internal angle is more than 180 degrees, so then this is convex polygon. So if the internal angle is greater than 180 degrees, then that is the concave polygon. Convex means all internal angles are less than 180. Okay. So this is about convex, this is about concave. Okay. Now this is about regular and irregular. So what is a regular polygon and what is irregular polygon? So regular polygon, all the sides should be equal. How the sides are? Sides are equal. If the sides of the polygons are equal, so and angles are also equal, so then that is regular polygon. So it is approximately equal. All the angles are approximately equal here, and all the angles are also here equal. Okay, all the angles, this angle, and this angle. If all the angles are equal and all the sides are equal in length, then that is the regular. Irregular means that is in irregular shape. Angles and sides, they are irregular in shape. Okay. Now, so this is about concave and convex. So convex means, so all the angles should be less than 180 degrees interior angles. Then if more than 180 degrees, then that is concave. Now simple and complex. Simple and complex polygons. So what is a simple? Simple means simple in structure. Complex means that is complicated in structure. So here simple polygon has only one boundary and it does not cross over it. So one boundary, it does not cross over it. But in complex, this is cross over it. This is cross over it. So this is the complex structure. So here how many sides we have? 1, 2, 3, 4, 5. This is pentagon. This is pentagon. And here how many sides? 1, 2, 3, 4, 5. This is also pentagon. Both are pentagons, but this is simple and this is complex. In simple, the structure is simple, bounded by a single line only. It is not cross over it, but here it cross over it. Okay. So this is the complex polygon, this is the simple polygon. So this is the pentagon. Here we have 5 sides, 1, 2, 3, 4, 5. This is pentagon, this is also pentagon. 1, 2, 3, 4, 5. Okay. So both are pentagons, but one is a simple, other one is a complex. So these are the types of polygons. So how many types? Regular and irregular pentagons. Then after that, concave and convex pentagons, not pentagons, polygons. First simple, complex polygons. After that, concave and convex polygons. Then after that, simple and complex polygons. So these are the types of polygons. So what is polygon means? Polygon means many angles. Okay. Okay, students. Yes, now the students, next concept, measuring and drawing lines, line segments, line segment, trace, whatever. See here, again whatever we did, line segment, trace, again we recapitulate. See here, the first one, lines. Then what is a line? So we know that line. So line, so it extends in both the directions. In both the directions, the line is not having a fixed length. Why? Because it is not having a fixed length. It extends in both the directions. So that is why where it ends, we are able to say that. So that is why the length of a line segment is not fixed. So that is why, so we are unable to measure the line. Okay. Then how to represent this line? The representation of a line, here A and B points are given on the line. So we can represent AB line like this by keeping 2 arrows on AB. Otherwise BA. So BA, so keeping 2 arrows like this. AB keeping 2 arrows, we can represent AB line and BA. So BA is also AB. How? So that is your wish. So either you want to represent AB, so by keeping 2 arrows on AB, so that represent a line, and BA. So by keeping 2 arrows on BA, so that is also represent the line only. Okay. So these are the 2 methods to represent a line. Okay. Now the second one, line segment. So already we know that what is a line segment. A line segment is a part of line. It is one part of a line. Segment, line segment. Line segment means it is a part of a line. Part of a line. So it has 2 endpoints. So once the line segment is having 2 points, 2 endpoints, that means the length of a line segment is fixed. The length of line segment is fixed. So that is why, so we are able to measure the length of a line segment. The length of a line segment. See here, here CD. CD is a line segment. It has 2 endpoints. This is the one endpoint, this is another endpoint. So 2 endpoints we have for this line segment. So how to represent this line segment? CD, so we should take CD and keeping like this line segment on CD. So this is nothing but CD line segment. Or otherwise you can represent DA line segment, DC. So DC, so like this. if you write CD, so keep line segment on a CD, so then that is line segment, and DC also a line segment. That is your wish. If you want to write CD or DC by keeping line segment on it, so that represent line segment only. Okay. Now this is about line segment. Now ray. So what is a ray? So ray means, so the ray, it's having one end point. A ray is having one end point and it extends infinitely in one direction. The ray is having one end point, it extends infinitely in one direction. It extends infinitely in one direction. Now E is one end point, E is a one end point, and F is on F direction, it extends infinitely. So the ray is also a part of line. Ray is also part of line. Line segment and ray both are the part of line only. Okay. So but this ray is having one end point, it's having, so it extends infinitely in one direction. Okay. So now the length of a ray, we cannot measure the length of a ray. So why? Because here in F direction it extends infinitely. Where it extends, we are able to say. So that is why we cannot measure the length of a ray. Then how can we represent this EF ray? We should represent EF ray like this. EF, we should write EF and keep an arrow on EF. So this is the initial point. Initial point you should take first. Initial point you should take first. Don't write FE like this. This is not correct. This is not correct. So in line segment, if you change the order of the alphabets, nothing will happen. But in case of ray, so we should write EF. If initial point we should write first and the next point we should take after that. Then you keep arrow on EF. Okay, that represent EF ray. So E means this is the initial point. So this is the another point. Okay, this is about the line segment and ray. Now after that, here, so here draw a line. He is asking to draw a line. First we should draw a line AB. So AB line we should draw first. This is a line. This is a line we should draw first. AB line. Here we have A and here we have B. AB is a line. AB is a line. Okay. Then after that, AB is a line. Draw a line segment CD. So that intersect AB. So draw a line segment. Line segment, we should draw a line segment. Whatever the line segment, how? So this is the line segment. This is the line segment CD. CD is a line segment. So he is saying only CD. CD is a line segment. Draw CD is a line segment. So which intersect, this intersect AB. This intersect AB, you see. So label the point, so that intersect, so label this point where, so here the point of intersection is T here. Where it intersect AB? At a point T. So then after that, draw a ray EF parallel to CD. So we should draw a ray we should draw. EF ray, which is parallel to CD. These two are parallel to each other. These two are parallel to each other. EF. Then E is the initial point and F is another point. This is the ray. This is the ray. EF is a ray. Okay. So this is the ray. This is the line segment. So the ray, so EF is a ray. E is the initial point. F is another point. E should be always, we should take initial point. These two are parallel. See, in this way we should draw. So first we should draw CD line. CD line we should draw. So which intersect AB at a point T, and after that we should draw another ray. So which is parallel to CD, which is parallel to CD. The ray name is EF. EF is a ray. So in this way, whatever the data is given, according to the data, you should think and you should draw. Okay. So what he has given, according to that you should draw line, then line segment, then ray. How the line segment and ray both are parallel, you should take parallel. Okay. Okay students. Yes, now the students, next concept. So we are going to discuss, we are going to learn about triangles. The next concept is triangles. So what is a triangle here? See, a figure bounded by 3 line segments is called a triangle. Here see one thing, so the triangle is also a polygon. Triangle is also a polygon, but here three-sided closed geometrical figure is a triangle, three-sided. So 3 line segments, 3 sides means 3 line segments. So what is a triangle? A figure bounded by 3 line segments, 3 line segments. So a figure bounded by 3 line segment is called a triangle. So that 3 line segments, what the 3 line segments called? The 3 line segments called sides. The 3 line segments called sides. Okay. So now here, so triangle examples given. See here. So here, so this is one straight line, one line segment, this is another line segment, this is another line segment. Total how many line segments we have? 3 line segments. First line segment, second line segment, third line segment. This is a triangle. So these 3 line segments are called sides. Here, first line segment, second line segment, third line segment. This is also a triangle. So these 3 line segments called sides. Here, first line segment, second line segment, third line segment, 3 line segments, 3 line segments. So with the 3 line segments, so this figure is bounded with 3 line segments. So this is a triangle. So here, first line segment, second line segment, third line segment, 3 line segments. So all these 4 figures are bounded with 3 line segments. So these 4 figures are called, these shapes are called triangles. So why these are called triangles? These are called triangles because these 4 figures are bounded with 3 line segments. 3 line segments. All these are bounded with 3 line segments. If a geometrical closed figure bounded with 3 line segments, then that is a triangle. That 3 line segments are called sides. Okay. So these are the examples, these are the figures of triangles. Now in the similar way, some pictures are given, some figures are given. See here. So this is first line segment, second line segment, third line segment, fourth line segment, 4 line segments. So here 4 line segments we have, so that is why it is not a triangle. Triangle is having only 3 line segments. The next one, 1, 2, 3, 4. 4 line segment, 4 lines bonded with 4 line segments. These 2 are closed figures. So bonded with 4 line segments. So here 1, 2, 3, 4, 5. 5 line segments. 1, 2, 3, 4. 4 line segments. Some are bonded with 4 line segments and some are bonded with 5 line segments. So this is the open figure. So this is not bonded. So that is why all these figures are not triangles. Why? So here some of the pictures are, some of the figures are so bonded with 4 line segments, some are bonded with 5 line segments, some are open figures. So that is why, so these are not triangles. Triangles are having only 3 sides, only 3 sides. So the figure so bonded with 3 line segments, bonded with 3 line segments is called a triangle. The 3 line segments are called sides. The 3 line segments are called sides of the triangle. Okay, students? Okay.